All right, so now I'm going to talk about how you could have this use the actual clock so that you don't have to press the button. And there is a clock on the Basys board. I can't remember how fast it is, but it's really fast. And so if you had this going on the clock edge, they would all appear to be lit up at once. And so what you have to do to use it as the kind of clock you would want would be to slow it down. But if you look in the constraints file, the clock signal that's there, that's the one you would use as the clock. And so the one that's in the constraints template. And so let me get to this. And so you would have that as your clock signal. But then you have to slow down the clock. When the other professor teaches this, we usually do this as a separate module. But you can do it inside your main module as well. You don't have to have a separate module. But it was, I think I counted 30 million. So for every 30 million ticks of the system clock, I wanted one tick for us. So I want our clock to be 30 million times slower. And so what you can do is I made a new variable that I called slow clock. So clock, CLK, was still my input. I'm still inputting the clock from the board. But then I have another variable that I call slow clock. And then here's how I make this happen. First of all, I need a count. I need to have a variable that can keep track of my count because I want to count up to 30 million. And so I needed a variable that was 26 bits or 25 bits. I think I only needed 25, but I made it 26 to be my count variable. So I needed to have enough bits to hold a number that was bigger than 30 million. So that's why it's 25 to 0. That's my count variable. And then always at the positive edge of the real clock, I counted. And if I got to 30 million, if count equaled 30 million, then I would reset my count to 0. And I would toggle this thing that I called slow clock. So every 30 million times that the regular clock had a cycle, the slow clock would have one cycle. And so if it got to 30 million, then it says toggle the slow clock. Else, add one to the count. And so it's keeping track of the count, so the count is going 1, 2, 3, 4, 5, 6, 7, so forth. And each time it's not 30 million, so each time it's just adding 1. And then when it gets all the way up to 30 million, then slow clock, which I think I initialized to be 0, it'll make slow clock, it'll toggle it, and then slow clock will become equal to 1. And the count will start back over. 0, 1, 2, 3, up to 30 million, and then it'll get to slow clock, and it'll toggle it, and slow clock will be 0. So slow clock is going 0, 1, 0, 1, 0, 1, but it's doing it every 30 million times of the clock on the board. And then The only difference in the rest of the code is this always block is always at the positive edge of the slow clock. And let me show you how this one works. Was I not sharing the screen the whole time? No, I wasn't sharing the screen. I wasn't sharing the screen. Sorry. I'm sorry. Oh, okay. I will share the screen and show you what I was talking about after I show you how it works. Okay. So I'm not doing anything, it's just doing its own thing. Are you counting to 30 million in your head? I'm impressed.
Trying to think about.
So it's really 60 million because it's
toggle.
only going in the positive edge. It's only when it goes from 0 to 1. So when slow clock goes from 0 to 1, that's when this moves. So at 30 million, it toggles to either 0 or 1, and then another 30 million, it toggles back. Okay, so I'm going to share my screen for you now, Andrew, so you can see what I was talking about. Okay, so this right here, this was the code that I put in to make the slow clock. So I also had reg slow clock, and then I had this count variable that was 26 bits wide because it needs to be pretty big, and then always at the positive edge of the system clock. I am sharing now, right? Yes, good, okay. All right, and then always at the positive edge of the system clock. If I reached to 30 million, then I toggled the slow clock and reset my count. Otherwise, I added 1 to the count. So this was the code that I used here. And then in my constraints, I used the clock code that's just in the template. So it's just the clock code that comes, the regular clock code, and it looks a little different. And then in the source code, the thing that's different is I have that other variable for slow clock. So clock is still my input, and that's still the system clock. Slow clock, I make that, and I do that code that I was showing you. And then there's no change in the first always block, and the only difference in the second always block is it's on the positive edge of the slow clock. So any questions on that? All right. Okay, so that's just your little extra for experts. And I'm going to stop this. And